Hello everyone. This is in continuation with our testing of hypothesis related problems. The next problem is LWP is a large multinational company having more than 2000 employees under its payroll. The management of the LWP company has introduced an intensive and comprehensive training program for its managerial level employees. There are four different types of training programs currently under consideration. Employees were divided into four groups and different groups were given different training programs. Now, the management of LWP wants to examine the effectiveness of these training programs, that is, whether these programs have been resulting into some managerial skill enhancement or their degree of effectiveness is different. Simultaneously, the management also wants to examine whether there is some change in the effectiveness degree with the level of experience of employees. Management believes that these two factors are independent. There are five categories of experience levels as envisaged by the HR department of LWP. For this dual purpose, 20 employees were randomly chosen according to a particular scheme. 5 employees were chosen from each training program, and in each subgroup, 5 employees belong to 5 different experience categories. The employees thus selected were given a managerial skill aptitude examination to examine the managerial aptitude, and their scores are tabulated in the form of a table, following table. So here we have experience category in years, 0 to 2, 2 to 5, 5 to 10, 10 to 15, more than 15. Then those four different training programs, 1, 2, 3, 4. So then they captured this scores, how much score under each category or each combination people have got. Now the question is analyze the data and examine the following perceptions. First question, the four training programs are equally effective in enhancing the managerial skill of the employees. There is no significant aptitude difference among employees of different experience categories. Use 5% level of significance and comment on the results. Primarily, the training program is defined as 1, 2, 3, 4. You will also define this experience category, the first one as A, this as B, this as C, this as D, and this as E. Now, from the question, we are supposed to check whether the effectiveness of the training, is it significantly different due to the different programs, different training programs? That is one test we have to do. Other one is, does it vary because of the experience category? Means, first of all, let us define, let mu A equal to population mean score, or I will define in general as mu I. I'll define it in general as mu I. Then I can say I takes the values A, B, C, D, and E. Population mean score obtained uh, who falls under experience category I. Here I takes the values A, B, C, D, and E. So that is first definition of population mean. And then we will also define, let mu J equal to population mean score obtained who has undergone training J. Here our J values are 1, 2, 3, and 4 because there are 4 training categories, training programs. I will say training program J. Okay. Now to test whether this the population mean score, is it the same for each experience category? Or another one test is that the population score is the same by having undergone training program 1 or 2 or 3 or 4, will it be the same or is there significant difference between them? So that means the above is a test concerning with more than 2 population means. 2 population means. Hence, we will use Z test. As it involves 2 tests. What are those? Between training programs and between different experience categories. Experience categories. Okay. So now based on this, we will define. So as it involves so and so, we will do a two-way analysis of variance, ANOVA. Now test one. What is that test one related with? Between rows or experience categories, between rows or between experience categories. So for this test, the null hypothesis will be H naught. Experience categories, we defined it as mu A, whether it is the same as mu B, whether it is the same as mu C, whether it is the same as mu D, and whether it is the same as mu E. That will be your null hypothesis. Then alternative hypothesis will be at least 2 of the above are not equal. Then comes your test 2. That is between columns, or we can say between training programs. That we already had defined. H naught is mu1, whether it is the same as mu2, whether it is the same as mu3, whether it is the same as mu4. Again, H1 will be at least 2 of the above. Population means, here also I'll write, here population means are not equal. Now what we do is the data given, we can simplify these numbers by taking an origin, because whenever we calculate variance, taking an origin will not have any effect on the variance, right? So we will take an origin, say we'll take an origin as 20. We will take the origin as 20 to the data given, so that all the values can be subtracted. Why I took 20? Because somewhere it is the middle, approximately middle. All the values can be subtracted with 20, basically to simplify the data. Basically to simplify the data. So once we do that, we get the data like this. First number 10, 20, 10 like that. Why I wrote the same? I could have changed it. I'll change it. I'll subtract it and change it. First one, it is actually 10 earlier given. So I have to subtract 20. So you will get what? Minus 10. Likewise, 20 minus 20, it will become 0. So let me update and make a new table. First one will be negative 10. Then we have 0. Then we'll have negative 10. Then we will have 10. Then second row, we'll have negative 10. Then 10. Then negative 15. I am subtracting from the original data everything with 20 to get these values. 0, 10, negative 10, 0. And then 5, 10, 0, and 0. Then 5, 20, 0, 20. Now let us calculate the totals. For the first one, the total will be negative 10. Second one, the total will be 15. Third one, it will be 0. This will be 15. This will be 45. Now here, columns. First column, it will be minus 10, then 50, then minus 35, then 60. Then we will have the grand total. This is 60, 60 plus 15 is 75, 75 minus 10 is 65. That means our grand total, which is GT, is 65. Now, what is the next step? Finding out the correction factor. Correction factor is calculated as grand total the square divided by number of observations, total number of observations, which is 65 the square divided by, we have how many values? 4 into 5, 20 values. So divided by 20. If I evaluate this, I will land up with 211.25. That is our correction factor. The next step is to proceed with finding out total sum of squares. How do we calculate? Each observation we need to square. Minus 10 square, like that. Minus 10 the square plus 0 square plus minus 10 the square plus and so on. The last observation is 20 the square minus the correction factor. So if we evaluate this and then subtract it with the correction factor, we'll land up with 2563.75. So total sum of squares, will define it as TSS. Then comes next one, row sum of squares. Till this step, it is similar to whatever we did in one-way ANOVA, same steps. Row sum of squares. First row, it is minus 10 the square and it has got 4 values. Each row total has got 4 values only. So I can write it like negative 10 the square plus 15 the square. I am not individually dividing because everything you have 4 observations. Together I can write 4. All will be divided by 4 because every observation is made out of 4 observations. Every value is made out of 4 observations minus the correction factor. If we evaluate that, we get 432.5. Then next one we have to do. This is addition to whatever we did in one-way ANOVA, because here we are going to do both row analysis as well as column analysis. It's a two-way analysis. So column sum of squares, we have to calculate here as addition, which is CSS. Each column, if you look into negative 10 made out of 5 values, 50 made out of 5. Every value is made out of 5. There are 4 different values. So negative 10 the square plus 50 the square plus negative 35 the square plus 60 the square. All these are to be divided by 5 because everything is made out of 5 values minus correction factor. This, if we evaluate, we will get 1273.75. So we got total sum of squares, row sum of squares, column sum of square. Now we can find out what is the error sum of squares, which is ESS. How do we calculate? Total sum of squares minus of row sum of squares minus of column sum of squares. Sorry. Now, this will give us row sum of total sum of squares is 2563.75 minus 432.5 minus 1273.75. So if we evaluate that, we'll end up with 857.5. Now we got all the values. We can create the ANOVA table now. ANOVA table. Between rows. How many rows are there? There were totally 5 rows. 1, 2, 3, 4, 5. So degrees of freedom correspondingly, it will be 5 minus 1, which is 4 degrees of freedom. How many columns are there? If you look into, there are 4 columns. So degrees of freedom will be 1 less. So 4 minus 1, it is 3. Total observations, we know it is 20. So degrees of freedom will be 20 minus 1. So it becomes 19. Error degrees of freedom will be the balancing figure, which means 19 minus sum of these two, which is 7. So 19 minus 7 becomes 12 degrees of freedom for error. Now, sum of squares of rows, we know it is 432.5. Sum of squares for columns, we know it is 1273.75. Error sum of square, it is 857.5. Total, of course, we know it is 2563.75. Now, mean sum of squares, how do we calculate? Sum of squares divided by the corresponding degrees of freedom. You will get 103.13. Then the next one, 1273.75 by 3, you will get 424.58. Then error sum of squares, similar division, you will get 71.458. What is that 71.458? 857.5 divided by 12, you will get that. Now, F ratio for rows, you will have to compare this mean sum of squares divided by the error sum of mean error sum of squares. Means 103. I think I will write the inference separately so that I get some good space. Yeah. Yeah. So here we will have mean sum of squares of rows, which is 108.13 divided by error sum of squares, which is 71.458. If we evaluate that, we will get 1.513. Same way for columns, 424.58 divided by 71.458, we will get 5.942. Now, F table value, we need to check F table value for the corresponding numerator and the degrees. I mean, for rows, the degrees of freedom will be, we will write first the numerator degrees of freedom. Numerator is 108. The corresponding degrees of freedom is 4. Denominator is 71.458, which is this error sum of mean sum of squares. Corresponding degrees of freedom is 12. Same way, for columns, the degrees of freedom will be, see, if you look into this, 424, it is here. Corresponding degrees of freedom is 3. Denominator 71.458, the corresponding degrees of freedom is 12. So it is 3, 12. Now we need to identify the table value for this degrees of freedom. Considering the numerator degrees of freedom as 4, denominator degrees of freedom as 12, what is the table value for a 5% level of significance? I think here they gave us 5%. Yes, 5% they give. So we will have to do that. So now the table value, I think it is 5%, right? It is given in the question 5%. Yeah. So for 5% level of significance, we have to verify the tables for 4, 12 degrees of freedom. 4 you have to see in the numerator's degrees of freedom. 12 you have to see in the denominator's degrees of freedom. If we do that, for the first one, we get the table value as 3.26. In the second one, we get as 3.49. So now we will come to the inference part. We'll say test 1, since F calculated value is nothing but this F ratio. This is F cal or F calculated value is 1.513. This is lesser than F tab, that is F table value. This is F tab, which is 3.26. Since it is lesser, we accept H naught. Null hypothesis we will accept for the first test. Means we conclude that there is no significant difference between those population means. That is the first inference. Test 2, since F cal, which is 5.942, is larger than F table value, which is 3.49, we reject H naught. We reject H naught. So that will be the conclusion for this particular problem, right? That means when we reject H naught, means we accept, means we accept H1, means there is a significant difference. That is what will be our conclusion for the second test. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you very much.